Okay, so for section 5.4, we're going to take a look at how to solve a logarithmic equation. So in order to do that, we need to use the following property of equality. If we have log base b of x equal to log base b of y, then x must be equal to y. So if you have two logarithms set equal to each other with the same base, emphasis on they have to have the same base, the interior arguments must be equal to one another, the x and the y. All right? But due to the restrictions that we have on logarithmic functions, we're going to need to check for extraneous solutions, which will occasionally come up. All right? So to do that, you need to ensure that the solution does not create zero or a negative number for the argument inside the logarithm. Okay, so the value itself for x could be 0 or a negative, but you have to make sure that when you plug it back into the expression in the argument inside of the logarithm that you don't get a negative or 0 there. All right, so we'll talk through that as it comes up. So we're going to go through 3 examples of these particular types of problems. All right, problem number 1. Solve each equation and check for extraneous solutions. Those are your general directions. So right here, here's what I notice. I've got log base 7 and log base 7. They have the same base, meaning the arguments must be equal. Okay, so I'm just going to simply do 2x plus 3 from the first argument equal to 9 minus 2x from the second argument. I'm going to add the 2x over to get 4x plus 3 is equal to 9. Then take away the 3 to get 4x is equal to 6. And then divide out the 4. And we're going to get x equals 6 over 4, which reduces down to 3 over 2, or 1.5. And now as far as checking for an extraneous solution goes, all I really need to do is take a look right here and ask myself, if I plug in 3/2 or 1.5, do I get a negative or 0? And when I plug in 3/2 right here and right here, I'll get a positive on both sides, which is a good thing. So this is in fact our final solution. Okay, so it's not an extraneous solution here, and the decimal is fine as long as you don't have to round that decimal. All right, problem number 2. Now I want to remind you, this is not a typo. This logarithm doesn't have a base. This is the same thing as having log base 10, but it's not really necessary to write that. Because the bases are the same, the arguments must be equal to each other. So 5x plus 16 is equal to x squared plus 5x. All right, if I subtract the 5x's here, they cancel off completely. So those will both be gone. Okay, and I'll be left with 16 is equal to x squared. I can solve that by square rooting both sides, which is going to give me x equals plus or minus 4. And now I need to check for extraneous solutions. So I'm going to do that on the side. This one, I believe, has an extraneous solution. All right. When I do x equals positive 4, I'm going to get from the 5x plus 16, 20 plus 16, that's a positive. And then from the other side, I'm going to get 16 plus 20, also positive, so that one works. If I try plugging in x equals negative 4, I'm going to get negative 20 plus 16, which equals a negative. That's not allowed. So I don't even need to check the other one. The negative 4 I cannot keep. So the final answer is just going to be x equals 4. X equals negative 4 is extraneous. All right. One more example like this. On problem number 3, we have log base 2 of x minus 3 equals log base 2 of 2x plus 5. So I can just set the arguments equal to one another. Let's say I'm going to subtract the x to get negative 3 equals x plus 5. Subtract the 5, and I'm going to end up with x equals negative 8. Getting a negative number is okay for the value as long as it doesn't make the argument negative. So let's check. If I do x equals negative 8 into negative 8 minus 3, that gives me a negative, which is not allowed. Okay, that's negative 11. And the same thing happens with the 2x plus 5. That would give me negative 16 plus 5. And while it's still negative 11, it's still a negative. So this is extraneous, which means this one has no solution. So it's possible to get a no solution. You could get one solution, two solutions. You could get two solutions where one is extraneous, or you could potentially end up with no solution. All right, so that's the first type of logarithmic equation. In the next video, we're going to take a look at how to solve a different type of logarithmic equation.